Next we are going to start electrolysis. The next chapter is electrolysis. As you can see it. What is electrolysis? Now electrolysis can be broken into two words. Electro and lysis. Electro means electron or electricity and lysis means pertaining to. So in this particular chapter we are going to study about the electricity or the electrons which is pertaining to. Alright, means the flow of electron and electricity, how it flows. What is the phenomena responsible for it? How, what are the conditions required for it? Everything in details. That is known as pertaining to. We are going to study about it. About electrons or the electricity. That is called electrolysis. In other words, I can define electrolysis as it's a decomposition of a chemical compound, that is electrolyte. The chemical compound here is the electrolyte in the aqueous solution or in the molten state or in the fused state. What I said, the decomposition of the compound. Got it? The compound means here is the electrolyte. Got it? The chemical compound. In the aqueous state, the compound is in which state? In the aqueous state, or it is fused or molten. Fused means molten only. The other word for fused is your molten. Got it? State by the passage of direct electric current resulting in the discharge of ions in neutral forms at the respective electrodes is known as electrolysis. That means, in simple words I can say, we will be taking an electrolyte and we will pass electric current through it. Direct electric current means from the battery. The current which you are getting in your house now, that is your alternating current. You have read in physics. That is known as AC, alternate current. Alright, and the current which you are getting it from the battery, that is said to be as a direct current. You might be knowing this also. That is, this is your AC, alternate current. This is known as a sine wave, sinusoidal wave. And this is your direct current, DC. This is your direct. We saw the direct current in this way, DC. And we saw the alternate current in this way, AC. We can say that. Clear? This is your axis. This is your axis. The y-axis, this is your x-axis. The same thing. It is your axis. It's the y-axis, is the x-axis. So here we are having, in case of AC, we are having the positive and the negative half cycle. Positive half cycle there is a current, negative we don't have. Alright, this is also called a sinusoidal wave or the sine wave, it is known as. In trigonometry you have read it, sine, S-I-N, sine, cos, tan, in this way. Clear? And here it is nothing but it is the DC current. This is a direct current, we can say that. Clear? The current is going in this particular direction and it is in only in the positive direction. In the negative axis we don't have. Like in AC, in the negative axis we have, but in the DC we don't have in the negative axis. Only we are having in the positive axis only. Got it? Fine. So we are going to pass a direct current. Direct current we always get it from the battery. Alright, from the battery we are getting. We are using the battery in your house, or you are using the battery in your torch or the different, what you can say, electronic gadgets, you are using the battery or not. That is, in the watch you are using the battery, in the mobile you are using the battery, that is the battery. So that current is your direct current, we can say that. Clear? But the current which is available in your house, which is coming in your house, which is supplied in your house, the domestic current, that is known as your AC current, the alternate current. So here you need to pass a direct current into an electrolyte. Electrolyte should be either in the fused state, that is in the molten state, or in the aqueous solution state. Aqueous means what? You are going to dissolve the compound in water. That is called aqueous solution state. Then you will see it dissociates into its ions. It dissociates. Alright, use the word dissociation. If it's an ionic compound, use the word dissociation. I will tell you later on also the difference between dissociation and ionization. It dissociates into its ionic compound. We can say into its ions. And these ions gets collected in the form of neutral atoms or molecules at the respective electrodes. Got it? At the respective electrode, it gets collected, and this phenomena is known as electrolysis. This is known as electrolysis. Again I repeat, you will take, that is the compound. For that purpose you need a cell, that is an electrolytic cell. This is a vessel. You will be taking a vessel which is an electrolytic cell. Generally the vessel is made up of glass, or it's made up of glass or silica crucible. Why do we use glass or silica crucible? Because it will not be attacked by the electrolyte. The electrolyte which you will be using it now, electrolyte may be acids, it may be bases, it may be some neutral substances. They will not attack the glass or the silica crucible. That's point number one. Point number two, it can withstand high temperature also. Suppose when you will pass current through it, temperature is going to rise. It can withstand high temperature because under high temperature the vessel should not crack. So for these two reasons, that it should be what you can say inert towards the reagents or the chemicals. The vessel should be inert, means it should not react with it. Alright, and the second thing is that it should be temperature resistant. Alright, it should be temperature resistant. For that purpose, we are using what you can say an apparatus which is either made up of glass or silica crucible. You have seen silica crucible in your lab, the white color, the bowl, this sort of, that is on a silica crucible. Got it? Now here you will be using the electrolyte, here the electrolyte which will be in the aqueous solution state, or it will be in the molten state, which is also called as fused state. Now here you will be using two electrodes. You will be using, generally we use the graphite electrodes here, graphite, because graphite has got no reaction with the electrolyte, because graphite is inert in nature, we can say that. We use basically the graphite electrodes or the carbon electrodes or the iron electrodes. They are inert in nature, they do not react with this acids, bases or the salts or the neutral substances. Means, I mean to say in one word, the electrolyte, it does not react with it. Okay, now this is being connected to a battery. This is the sign of the battery, you know it. This is the positive terminal and this is the negative terminal of the battery. So this is positive electrode and this is your negative electrode. Alright, listen here, this is connected to the positive terminal of the battery, so this is your positive electrode, and this is being connected to the negative terminal of the battery, so this is your negative electrode. The positive electrode is otherwise known as here anode, and the negative electrode is otherwise known as here cathode. Alright, the positive electrode, why it is called positive electrode? Because it is connected to positive terminal of the battery. Why it is called negative electrode? Because it is connected to the negative terminal of the battery. This is negative. In this way, negative terminal is called as a cathode and the positive terminal, positive electrode is known as the anode. Alright, fine. So, what you got it is that when you pass electric current through it, then you will find it out that the ions, here the electrolyte will dissociate into its ions, and these ions will go to the respective electrodes. Either it will go to the anode or it will go to the cathode. If it is metals, metallic ions, or if it is hydrogen ions, remember it, metallic ions and the hydrogen ions, which are positively charged ions, they will go to the cathode. Because what I said, metallic ions or hydrogen ions which are positively charged, they will go to the cathode. Why? Because cathode is negative. So positively charged ions will be attracted towards the cathode, because like charges repels and unlike charges attract. You read it earlier also. What in physics you have studied. So what I said, the positively charged ions, which are positive, again I repeat, the hydrogen ions or the metallic ions are the positively charged ions. They will go to the cathode, they will move towards the cathode because it will be attracted by the cathode, because cathode is negatively charged. And the negatively charged ions, which are negatively charged ions? The non-metallic ions. The non-metallic ions or the radicals which are negatively charged, like carbonate, sulfate, hydroxide, OH minus, or oxide, they are negatively charged. They will go to the anode, because anode is positive. They will move towards the anode, they will migrate towards the anode. So what you find is that the positively charged ions